What you're looking at right now is the benchmark of the world's fastest chip that can process up to 500 tokens per second, which is 10 times faster than some of the fastest LLMs like GPT 3.5. So the name of the company is Groq, and it's not Groq, which was developed by X, that is owned by Elon Musk. It's called Groq with a Q. So it's an AI company that has developed a specialized chip called the LPU, which is Language Processing Unit. Now, similar to CPU, GPU, which is Graphic Processing Unit, or TPU, which is Tensor Processing Unit. But the difference is this chip was specifically designed to improve the performance of large language models. And like I said, it can go up to 500 tokens per second, which is significantly faster than what we have today. Let me show you some of the public benchmarks. And with public benchmarks, I mean these are the benchmarks not done by the Groq team. So you can see these are the benchmarks for the 70 billion models, and it talks about output tokens throughput, meaning how many tokens it can generate per second. Now, 1000 tokens is equal to 800 words or something, right? And you can see Groq can generate 185 tokens per second, meaning it can write a 1000 word essay within 6 seconds. You can see the performance of some of the other chips or LLM inferences here. So you can see any scale has 66, which is I think the second highest. And then there's Together AI, which is 65. And then Fireworks on 40. And then there is Lepton AI on 33. And then our favorite Perplexity on 30. And then there are a bunch of different ones here. Replicators here, which kind of does 10 tokens per second, which is not too much especially after Groq, right? And you can see these are the average number of tokens returned per second. And I'm going to show you, they have a demo platform and it's super fast. Then there is the time to first token. This is the duration that the LLM requires to return the first token itself. And this is important because when you're chatting on websites or using chatbots in real time, so the second one is the time to first token. This is the duration of time that LLM requires to return the first token. So the minute you start chatting, let me see if I can show you an example. You can see this is the amount of time it takes for Google to generate this the minute I search for something, right? Let's say I look for something again. You can see this time is what the time to first token effectively is. Now, if we look at the benchmarks here, you can see Replicate takes the most amount of time. They take 1 second. Groq takes 0.22 seconds, which is 0.01 second more than any scale. It's still relatively very low, given the amount of words it's generating per second. I was watching a video on their YouTube channel from 5 months back where they achieved around 200 tokens per second word generation. And while the average here shows 185, if you really try it on their platform, it goes to around 400 tokens a second. So the question is, how the hell is it able to do all of this? Now, the reason is very simple. The traditional GPUs, CPUs, and TPUs focused on two things: hardware and software. So their bandwidth and distribution was always distributed in that way, and they used to work in sync. So it would wait for the hardware to respond, then it would wait for the software to respond. So there was always like an orchestration of sorts. Now with Groq, the design is simplified. So now it only focuses on the software side and they don't focus on hardware side at all. So the focus is software first. And the other feature is that they have deterministic performance, meaning the initial architectures of chips was that they had to do multiple transfers of data across before they get to the final point. Now in Groq's design, it's very simple. So it needs to take token from one point and then put the token on the point B. So the entire focus is on ensuring the improvement in LLM processing. And hence this is called the AI chip, which specifically focuses on large language models. The GPUs that you and I use were focused on image processing, which is why we would typically use those for gaming and machine learning use cases, but they weren't made for machine learning models. They were adapted for machine learning models, which is why this is very interesting. Now you can go ahead and look through these documents. They've kind of created a document on why AI needs a new chip architecture. and a bunch of different documents here. And I agree with them. Just pushing the current chips or GPUs to work on LLMs is almost like mixing a couple of oranges in apple juice. While you would still taste apple, it's not purely apple juice, right? So what these guys are now doing is that they're making it specifically for LLM processing only, because AI right now is at the peak of its capability, and yet we did not have an AI based specialized chip until now. While it seems Sam Altman and Nvidia are kind of racing to build an AI specific chip, it seems these guys have something already. Now, enough talk, let's go to their playground and let's actually try playing with the model. So how it works is that they have a couple of open source models here, which you can choose and post the prompt, and it will be able to generate the output for you. Now, once you log in here, there is, just like everything else, there is the disclaimer here, and you can choose to close this. Let's try putting in a prompt. I'm going to say write a 1000 word essay on global warming. And I use Mixtral's 32K model for this. You can see we have a couple of options here. Either ways, that's not something we should be paying attention to. The second I entered the prompt, this was already ready. And note that this is 1000 word essay, and it generated 418.65 token per second, which is insanely fast. ChatGPT or GPT 3.5, which is the turbo one, does 50 tokens per second. So you can imagine how much the difference in generation is, and you're using an open source model. Imagine a chip in your local system that is not going to impact your other applications and yet work on large language models locally like this. Let's try Llama 2 and try generating something else. Now this was for text. Let's see if it also works on code. You can see it's generating the code really fast, and it took around 4 seconds, but the token speed was relatively less, which is 281.35 versus what it did for text, which means code is probably a relatively or slightly heavier than writing plain language here, which is straightforward. Code kind of requires you to have conditions and stuff in place, and it kind of takes long. Or maybe having this code like area kind of made it slow, I am not sure. Let's try generating something else. Impact of AI on global warming. And I'm assuming this is going to be relatively faster because this is straightforward text. You can see it took 280.18 seconds. Thinking if this is with respect to how or which model we're working on. So let's say in this case, we were working with Llama 2 and it's around 280.18 seconds. Let's use the same prompt, but on the Mistral model and see if that changes anything. This is certainly way more faster, and it's 429.28 seconds. So it does also depend on which model you're using to generate this and the architecture of the model that you have in the backend. And we currently don't have too many models to test from here. We have Mistral and Llama 2 at our disposal, and I think both of these are still powerful models available in the open source space. Let's try writing the code for snake game in Python again, and see how long it takes to generate now. So these are the total active requests, meaning these are the amount of people using it, probably. So the code is generated and the speed is very fast now. Now, obviously, I'm not going to test the code here because I don't have my interpreter on, but I'm assuming this code is okay. And I'm just trying to see what the speed of the model is rather than the accuracy at this point of time. But looking at the initial piece of content here, it seems that the code and the content generated is okay. And then if I ask basic questions like, what's the square root of 4? It's not going to take too many tokens to respond to this, but you can see it's very fast still. Now the reason why it says end-to-end time here is 6.61 seconds, while the token speed to be 423.08 seconds, which would kind of take this less than, I think, 1 second. The reason is because there are multiple people using it right now, and it's also kind of adding the time it took for the queue to move forward, I guess. By the way, if you're wondering who did the benchmark, it seems artificialanalysis.ai was the company that did the benchmark. And I think that's all I want to talk about with the model. When it comes to the model itself, again, I didn't have to sign in order to play around with this. And you can see there are a total number of requests here. Again, my goal is not here to talk about the UI, but rather about the chip that they're building. And it seems very interesting. Something that all of us should definitely keep an eye out for. If models in the future become like a basic norm in every computer, then you will need a specialized chip in order to run those models locally. And this is one of those companies that is currently a little bit ahead in the game. So it makes sense to kind of keep an eye out for these guys and the kind of things they're doing in AI at this point of time. Alright guys, I'll see you guys in the next one.